So for these next two problems, these are two that you can try and then check your work with this, right? What mass of aluminum oxide is formed from 100 grams of aluminum and 150 grams of oxygen, and what mass of excess reactant is left over? So of course, I would start with 100 grams of aluminum and 150 grams of oxygen, and of course 0 grams of aluminum oxide. So your strategy is going to be to convert to moles, so filling out these two boxes, assuming that the aluminum is the limiting reactant, and subtracting these and seeing or making sure that you get no negative numbers. If you get a negative number, that actually means that oxygen was the limiting reactant, and you just do the problem with oxygen as the limiting reactant. And then you would go up here, again, by figuring out which one is the limiting reactant and using the coefficients from the balanced chemical equation. So pause here, do the rest of the work, and then come back and check your answers. Okay, so when you come back, you should have converted your aluminum to about 3.7064 moles of aluminum and 4.6875 moles of oxygen. Of course, I would start out with 0 moles of aluminum oxide. And then subtracting all of the aluminum, so assuming aluminum is the limiting reactant. So subtracting 3.7064 moles of aluminum, and it's not going to be the same moles of oxygen. I need to use the coefficients from the balanced chemical equation, right? Saying that 3 moles of oxygen will require 4 moles of aluminum, and that number that I get is 2.779 moles of oxygen. And I look at that, and I had 4.6, and I'm only using 2.7, so I'm going to have some left over. I have 1.907 moles of oxygen left over, which converting over to grams would be 61.0 grams of oxygen left over. I used up all my aluminum, so I have no aluminum left over. And how I find how many grams of aluminum oxide I made was by using, again, the coefficients from the balanced chemical equation. 2 moles of aluminum oxide would require 4 moles of aluminum, so I would go up by 1.853 moles of aluminum oxide. Since I started out with none, I would make 1.853 moles of aluminum oxide, and converting that back to grams, I would get 189.0 grams. And then adding those together, I noticed that I started with 250 grams of material, and I'm going to end with 250 grams of material. So that's a good indication that I've gotten this problem correct. And if I'm going to write a sentence trying to explain my logic, I would say something to the effect of, aluminum is the limiting reactant. So I only needed, right? You only needed 2.7 moles of oxygen to use up all the aluminum. Since I had more than that, right, 4.6 moles, the oxygen would be left over. And, of course, the aluminum will be used up, and thus is the limiting reactant. And number 56 is another one that you can try on your own. What mass of aluminum oxide is formed from 35.0 grams of aluminum and 25.0 grams of oxygen, right? I would start out with 0 grams of aluminum oxide. So pause, see if you can answer this question, and then come back and check your work. So again, I would convert these to moles, 1.297 moles of aluminum to start with, and 0.78125 moles of oxygen to start with. If I use up 1.297 moles of aluminum, I would also wind up using 0.9729 moles of oxygen by multiplying by 3 and dividing by 4. Well, that would give me a negative number. So I know that this cannot be the way that it is. I can't actually use up all my aluminum. I'm going to use up all my oxygen. And when I use up all my oxygen, I will also use 1.0416 moles of aluminum, meaning that left over, I would have 0.255 moles of aluminum, or 6.90 grams of aluminum. I would use up all my oxygen, so I have no moles and no grams left over. Using the coefficients from the balanced chemical equation, and now this limiting reactant that I have identified, I can figure out that I will make 0.5208 moles of aluminum oxide. Since I started out with 0, I will wind up with 0.5208 moles of aluminum oxide, or 53.1 grams of aluminum oxide. And again, if I look, I started with 60 grams of material and I ended with 60 grams of material. So that means I have done this problem correctly because the law of conservation of matter holds. And what would I say about my limiting reactant? Well, I would say oxygen is the limiting reactant, because in order to use up all my aluminum, I would also use, look back at that number, 0.9 moles of oxygen, and I only had, right, how much did I have? 0.78. Right, therefore, oxygen would run out first, and that is literally the definition of the limiting reactant.